Hello everyone, welcome to Miss Osborne's Homework Helper. This week I'm talking about the extra credit packet that looks like this, has this little flyer on the top and it has 5 pages. I'm talking about that this week, and this is due Monday, November 13th, so you have the long weekend to catch up on it. I've highlighted a couple of problems I'm going to do for us today. So I'm on the first page, which is comparing and rounding decimals. I'm going to be working on number 1. Number 1, it's asking me to compare each pair of decimals using greater than, less than, or equal to. So the first problem looks like this: 5 and 213 thousandths, 5 and 312 thousandths. Okay, whoops, I want to make sure you guys can see that. Let me scoot over. So I've written my workout here, and I'm going to start by looking at place values. You know what, I'm going to rewrite really quick. That's not very neat of me. 5 and 213, and then I have my little comparison circle in the middle. It's asking me which is it greater than, less than, or equal to. Okay, so the first thing I'm going to start by looking at is the place value. So here in the ones place, I noticed that both these numbers are the same. So I know, okay, it's equal so far. I'm looking at the tenths place. I have a 2 and I have a 3 in this place. Now, I know that 2 is less than 3. So that kind of solves my problem right there. I can kind of look and I see, oh, the hundredths place is the same. The 1 is in the hundredths place value. Then I have the 3, which is larger than the 2 in the thousandths place. But it all really comes down to the 2 and the 3 in the tenth place. I know that 5 and 213 thousandths is, oh, I drew it the wrong way, is less than 5 and 312 thousandths. So the answer for number 1 on the compare and round decimals page is less than. Let's move on to number 12 on this same page. It's another comparison problem. I'm going to set it up for us. It's 0 and 1/100 compared to 0 and 1/1000th. You know what? I'm going to change that center comparison circle to a square because I have so many zeros going on right now. So when I'm looking at this number, I know that there's no whole numbers involved, so it's equal up until that point. I know that there's no tenths involved. It's a 0 here and a same 0 on this number. Now this next one, the hundredths place, this is where the difference is. I know that 1 is greater than 0. So therefore 0 and 1/100th is greater than 0 and 1/1000th because the 1 is in the thousandths place. So your answer is going to look like this. Okay, I'm still on the same page because we haven't done decimals for a while. I just want to revisit some things with you guys. I'm on rounding to the nearest tenth. I'm on number 15. So I'm going to go ahead and write that number down. It's 7 and 953 thousandths. It's asking us to round to the nearest tenth. This is the nearest, the tenth place is here, so it's asking us to round to this place value. So in order to round to the tenth place, I need to look at the hundredths place, and I need to look at what that number is telling me, the 5. I need to look at what that 5 is telling me to do. Now, when I see a 5, I know it's telling me to round up. If it's below 5, it's going to stay the number that you're rounding is going to stay the same. So with a round up of 5, that actually makes this kind of tricky because it's already at 9, so that's going to turn into a 0, which is going to affect my whole number. So it's going to, the answer is going to look like this. Oops, I'm trying to do it on camera still. So when the 9 is going to be rounded, it's going to round to a 0, and I'm going to need to carry that 1 over. So rounded, the answer is 8 0/10. It's just 8. It turns into a whole number. Well, it doesn't, it turns into a whole number just because this one happens to be 9. Okay, let's move on to number 19. Number 19, still the same page. Number 19 is right here. We're going to be rounding to the nearest hundredth. So this one is 5 849 thousandths. We are going to be rounding to this place value, the hundredths place. So I need to look at this number. A 9, does it tell me to stay the same or does it tell me to go up? It definitely tells me to go up. So I know that that value is going to change to a 5. Oops, sorry, not far away enough. And then the new number is going to be 5 85 hundredths. This is the answer down here, because it's asking you to go to the nearest hundredth. Okay, I'm moving on. I'm going kind of fast because there's lots of pages, and I don't want to make this video crazy long. I'm on number 23, still on the comparing and round decimals page. This one is round to the nearest whole number. So I have 98 55 hundredths. Now if I'm rounding to the nearest whole number, I have to kind of look at the big picture here. So I need to look at, is this over? What does the 5 tell me to do? The 5 tells me here it needs to go up. So I know that I'm going to be rounding to 99. The 5s tell me I need to increase my value. So 98, the next whole number is 99. I hope that was a good review. That's from the first unit we did this year. This second page is a guided practice compare and round decimals. I'm not going to do anything from this page because it walks you through how to do it on this page. So now I'm going on to the next page, which is adding and subtracting fractions, and it's page number 10. Okay, so I'm on number 1. Number 1, right here, is 5 1/3 minus 25 sevenths. Now, I am going to be doing, oops, I want to be on camera here. I am going to be doing, adjust just a little bit. Go. Hopefully that's a little bit better. Still working on the angle and the view. If you guys can help me with that, if this isn't good or if this isn't working, please let me know. Okay, so I'm gonna circle my whole number. I'm gonna leave it to the side. I am gonna do the butterfly method really quick. I'm making my wings, making my antenna, making my body. 3 times 7 is 21. 3 times 25, I know that 3 times 5 is 15, so there's the 5, and I'm carrying the 1 over. 3 times 2 is 6, plus 1 more is 7 for 75. 7 times 1 is 7. So I have some new fractions. I don't want to forget about my whole number over here, so I'm going to bring it over. 5 7 21st minus 75 sevenths. Ooh, that's an ugly number. Or 21st, sorry. That's a really ugly number. So I'm at a point where I need to make a decision here. Whoops, let me move it this way. So far my work kind of looks like that. I'm going to rewrite it down here at the bottom. I want to make a decision about, should I borrow from the whole number so I can do some subtraction, or should I flip this whole number? I'm going to go ahead and borrow from the whole number just for the sake of practicing. So I'm going to go ahead and erase my butterfly. I'm going to rewrite this problem larger. 5, oops, you guys can't really see, 7/21 minus 75/21. Okay, so I'm going to borrow from my whole. So I cross out my whole number. I write the new whole number. I add the same number as the denominator, because then that's basically decreasing a whole. Because if it's 21 as the numerator and the denominator, then I'm basically calling that a whole. So 7 plus 21 is 28/21. And I know that's still not enough. Still not enough to do the subtraction. So I'm going to rewrite it down below for 27/21 plus 75, minus 75/21. Okay, so I need to borrow again, so that's going to become a 3. Add 21 again, so I'm now going down towards the bottom of my whiteboard. 27 plus 21 is 48/21 minus 75/21. I just did all that math. I'm still not at a place where I can subtract 75 from my other numerator. So I'm kind of in a little bit of a pinch. I'm going to go ahead and try one more time to subtract and maybe get a little bit closer. So I'm going to go up over here and do some work. I'm going to cross out down here. This is 2 and then plus 21 again. So now I'm at 2 wholes. 48 plus 21 is 69. Wow, I'm really, really close. 21st minus 75/21. So I'm going to borrow again. Now I'm down to a 1 already. So I'm, okay, I'm over here, down to 1. Sorry guys, this is messy. It's taking forever. Plus 21. 1. So that's 80/90 over 21 equals 75/21. Wow. Okay, I'm finally at a point I can now, looking up here, I can now finally subtract. So I have 1 whole and no holes on the other one, so I'm going to carry my 1 whole. 90 minus 75 is 15/21. So this is your answer for the first one on the adding and subtracting fractions page. It has the number 10 at the bottom. Now that took a long time to get to. You can also turn the second fraction in this problem into a mixed number, and that's another way you could solve. Okay, moving on to number 2 on the same page that has number 10 at the bottom, the number 10. Working on number 2. So this is 3/4 plus 1/3. Okay, I'm going to go ahead and do my butterfly model here, because this is a really simple one to do butterfly model with. Four times 3 is 12. 4 times 1 is 4. 3 times 3 is 9. So our new fractions are 9/12 plus 4/12 equals 13/12. Ruh-roh. 13/12, an improper fraction. I'm going to go ahead and turn that into a mixed number. How many times does 12 go into 13? Goes into 13 one time. How many are left over? So 13 minus 12 is 1. Your answer is 1 and 1/12. On to the next page. Now I'm on adding and subtracting fractions again, but I'm on page number 3 at the bottom. Okay, the first problem is 5 1/8 minus 14/4. Okay. So I think I learned my lesson last time. I'm not going to go crazy with the borrowing. I'm going to go ahead and turn that 14/4 into a mixed number. So I have it looks like 14/4. I'm going to turn it into a whole number. I'm going to back my camera up. That's a little bit better. That gives me more space. Okay. So I'm going to leave this 5 1/8 alone. And for right now, I'm going to work with the 14/4. How many times does 4 go into 14 evenly? It goes in evenly 3 times. 4 times 3 is 12. 14 minus 12 is 2/4. And because I bring the 4 down. So then I can just drop my other fraction right down. That's a lot easier to work with. And then I'm not going to do butterfly on this one because I know that 4 is a factor of 8. So I can just multiply it by 2 on the denominator and the numerator to make me have the same denominator. So I'm going to go like this. Okay, and I'll write my new fractions up here. I didn't do anything to 5 1/8 minus 3. You don't do anything to the whole number. The 2 times 2 is 4. And the 4 times 2 is 8. So now I have denominators that are the same. Whoops. Let me go back a little bit more. I have denominators that are the same over here. I'm going to go ahead and erase this part. And I'll rewrite it. 5 1/8 minus 3 4/8. But the problem I see is that my 4 is larger than my 1, the numerator here. I can't subtract from that. So I need to borrow from my whole number again. So my new number will be 4 wholes. 1 plus 8 is 9/8 minus 3 4/8. So now I can do my subtraction work. 4 minus 3 is 1. 9 minus 4 is 5. And then my denominator I bring straight across. So 5 1/8 is my answer. And that's for number 1 on page 3, adding and subtracting fractions. Okay, we're going to try number 2 really quick. And that is on the same page. Number 2 is 3/4 plus 3/7. And I'm not going to do butterfly with this one because I want to remind you guys of the other methods we have. So that other method is standard algorithm, where if we're trying to make our denominator the same, we think about a common factor. So trying to think, multiples of 7. 7 times 2 is 14. 7 times 3 is 21. 4 times 4 is 16. I can't get to 21, so I might just want to multiply them against each other. 4 times 7 is 28, so 28 could be my new denominator. So I'm just going to go times 7, because you do to the top what you do to the bottom. So now it looks like that. And I'm going to go ahead and do my work and rewrite it again down here at the bottom. I'm just going to draw a little squiggly line. 3 times 7 is 21. 4 times 7 is 28. 3 times 4 is 12. 7 times 4 is 28. So rewriting that, that's what it looks like. So now I have nice denominators. They're the same. So I just need to I need to carry my denominator over. I need to add 21 and 12 together. So I know that is 33. So, you're thinking, Miss Osborne, there is something wrong with this fraction. This is an improper fraction. I need to change it to a mixed number. So I'm going to go, okay, I'm going to do the work. How many times does 28 go into 33? How many times? One time. It goes in one time. 33 minus 28, how many are left over? That would be 5. And then my denominator, you bring it right over, and it's 28. You guys are good at that. You know that. Okay, so that would be my problem number 2 on adding and subtracting fractions, page number 3. I'm going to go ahead and promise you we're almost done with the examples. If you need more examples, you can email me, dojo me, call me. I will give you more examples. Okay, I'm on the last page of the packet. This is adding and subtracting fractions with the number 10 on the bottom. Now you might think this looks very similar to the other page. It is. It's similar, but it does not have the least common multiples information attached to it. I want you guys to challenge yourself. Try to solve this without that least common multiples attachment. And some of the problems are different. I'm going to do number 7 on this page, which is 7/9 minus 2/5. Looks just like that. Okay. So, I'm going to go ahead and do butterfly with this one. Or actually, I'll do standard algorithm again. So, I'm just going to multiply them against themselves because I know 9 times 5 is 45. So, I'm going to go 5 times 9, 2 times 9, 7 times 5, 9 times 5. Okay. So now I'm going to go over and rewrite my fractions. 7 times 5 is 35. 9 times 5 is 45. And I'm subtracting. 2 times 9 is 18. 5 times 9 is 45. Ooh, this is a really nice fraction. Like, really, really nice. Sorry, I'm going to pick this up for a second. It's really nice. We could just subtract right across. No problem. Okay, let's go ahead and do that. 35 minus 18. So sometimes I need some help with subtraction, so I like to line up the numbers this way. Okay, so I know I'm going to have to borrow here. And I know I'm going to have to, okay, say this is, Okay, so I need to borrow. I know that's 2, 15. So I have it crossed out the 2. Sorry, my cat was scratching at the door. 16 over 8, so I know that's 16, or sorry, it's supposed to be a 15. 7, 2 minus 1 is 1, so 17. So I can check that by going 17 plus 18. 8 plus 7 is 15. 35. That's that number. Okay, good. Math's all making sense. Okay. So, I know that 35 minus 18 is 17 over 45. So that's the answer to that problem. Okay, please let me know if you have any other problems or questions with this packet. I'll be on Nafa Dojo all weekend. You can also leave comments on my YouTube channel, and I'll try to check that pretty regularly. You can email me if you have questions. Tons of ways to reach me. I hope you guys take advantage of the 5 extra credit points. We don't get much extra credit in our class, so I'm hoping you guys take advantage of it and do your best work and show your work. Have a great long weekend.